Hey you guys, this is Mr. Sal. I got this question on the YouTube channel, and I thought it'd be better if I showed it rather than explain it in the reply. So, well, here we go. So the first thing on this one is that first equation actually is not necessarily in the standard form, even with three variables. So what I'm going to do is use the commutative property to move that 2x to the front. And then I'll add the 3y. But not only that, is I want to acknowledge that there's zero z's. So I'm going to put plus 0z, just so I can see how many there is, and then this equals 5. I'm going to do the same thing on the second equation, but right there I'm going to put 4x plus 0y's plus 2z's. Now this is usually a little bit more important when we're using matrices, but it'll work for what we're doing here as well. And on this third equation, we got 0x's, 6y's, 4z's, and 20. Now the video this came off of, we would be looking right now to combine two equations to eliminate one of the variables. But what we see on this is that the x is removed here. There's no x's here. There's no y's there. And there's no z's in this first equation either. So we already have one equation where one of the variables is eliminated. What this means is that we just need to use two of the other equations to eliminate one of the other variables, which would then give us one equation with one unknown or one variable. So, for example, most people would say, well, it's most common just to start by eliminating the x's. So this equation has an x that's eliminated. And I'm going to keep that right there. Okay, now what I'm going to do is I'm going to take the other two equations. Now I have these two equations, and what I'm going to want to do is manipulate them so that I have the coefficients of x that are opposites. Meaning I can see that 2, for example, is half of 4, or that 4 is a multiple of 2. What this means is if I can change this 2 from the 2x to be negative 4, and it will change these other values here, maybe not the 0, but the 3 and the 5 for sure. If I can change this to a negative 4, then it will eliminate the x's when I combine them. So to do this, I'm going to multiply this top equation here by negative 2. And now I have this new equation right here, negative 4x minus 6y plus 0z equals negative 10. Again, what I did there is I took this negative 2 and multiplied it by the 2, giving us negative 4. Negative 2 times 3 is negative 6. Negative 2 times 0 is 0. And negative 2 times 5 is negative 10. And of course, we kept the letters with those. Now that second equation, I don't need to do anything to it because I have a coefficient of x that's the same. So this is what I have now as a system of two equations. And if I just add all of these straight across, then we should see that the x's are going to eliminate or give us a 0x equation. So this is the new equation I have. And of course, with this 0x right here, I don't really need to show that I have 0x's. That's just the additive identity property. And of course, if we look here, negative 6 plus 0 is negative 6. 0 plus 2 is 2, so I got 2 z's. And negative 10 plus 10 is 0. So I have this new equation right here in blue, which I'm going to combine with the equation here to the left, this 6y plus 4z equals 20. If I combine it with this, then I should be able to find a way to eliminate the y's. So now I have this system right here to the left. And again, all I did is I moved this equation here with this green equation, which doesn't have an x. So I have two equations now without any x's that I can combine. So let's go ahead and do that. And not only can I combine these, I can combine these right now because the coefficients of y's are opposites, meaning that when I combine them or add them together, right, I got 6y minus 6y, that's 0y, which means they eliminate. Then I've got 4z plus 2z's, which would give me positive 6z's. And this should equal 20 plus 0, which is 20. Now, of course, we don't need to show 0y plus 6z. So now you can see, hopefully, we have an equation, one equation with one unknown or one variable. And to solve it, all I'm going to need to do is divide both sides by 6. And if I simplify that, 26ths, I should get 10/3. And that comes from dividing both of these by 2. So I got z equals 10/3. Now that I have this unknown, what I can do is I can go back to my 3 original equations, and I should be able to solve for the other 2 unknowns, my x and my y. So if I look at those 3 equations, this top equation here, it doesn't have a z to replace. So that's not really going to help, but the second equation does. And when I replace z, then I'll have one equation with one unknown, x. So this is the equation. Of course, I'm going to replace z with 10/3. And now I just evaluate this. So I can take 2 times 10/3, which would be 20/3, which gives me 4x plus 20/3 equals 10. Now I will subtract 20/3 from both sides so that I can get the x's by themselves. Now if it does help you on this one, for example, if you don't have a calculator which can change these into fractions, you just need common denominators. So I got 30/3 minus these 20/3, which would give me 10/3. And now I'm just going to divide both sides by 4. Alright, so I got 1x, which is what I want. And 10/3 divided by 4, that would be 10/12, which should simplify to 5/6. So I have an x value now. So now that I have this x and z values, I have 2 equations with y. I've got this third equation and the top equation right here. I can replace either x or z into these 2 equations and solve for y. Now, whichever one I choose doesn't matter. It should be the same either way. But that's not going to matter either because we are going to check in the end. So what we can do is, let's do this using the z first, and then we'll also do it using the x. And for the z, of course, I'm going to have to use that third equation. 6y plus 4z equals 20, but I'm going to replace the z value with 10/3. And of course, I will multiply 4 and 10/3, which would give me 40/3. So I got 6y plus 40/3 equals 20. Subtract 40/3 from both sides. And just for the sake of time, I've already done the subtraction there. 20 minus 40/3 is 20/3. And now, of course, I can divide both sides by 6. And without going into too much detail, this is something you should know. Y would then be 20/18, which simplifies into 10/9. And that right there is our y value. Now, if we did that right, we should get the same thing for the x as well. So what I'm going to do is use that top equation, 3y plus 2x equals 5, and I'm going to replace the x with 5/6. Now, if we did it right, if our x and our z values are correct, then we will get the same y value. If they're different, then we need to go back and figure out what we did wrong. Well, this is what I get out of that. From 2 times the 5/6, I got 5/3. Now we'll need to subtract 5/3 from both sides. And 5 minus 5/3 is 10/3. And then finally, when I divide both of these sides by 3, I'm left with the y equals 10/9 once again. And that one didn't take any simplifying, but we can see that the 2 y values are the same. So when we come up here to write our answer, we'll write it as a ordered triple. So I got my parentheses, I got my x value, which was 5/6. I got my y value, which is 10/9. And my z value, which was 10/3. Now you could have used a matrix to solve this. If you did use a matrix or a matrix, you'd need all of this stuff, okay, to change it into an augmented matrix, and then you'd use your elementary row operations to work on those. But again, I hope this helps. This is just using the same technique from the video that this question was left for. So thanks for watching, you guys. Again, I hope it helps, and we'll see you guys next time. Good luck on your math stuff.